Welcome to another exercise from the workbook Statistics. This time I'm going to talk about a hypergeometric distribution and an exercise on this topic. So let's have a look at the exercise. Here we have a university has campi at 3 different locations where they offer bachelor and master programs. The share of students that quit their studies are summarized in the table below. So that's the table here for bachelor students, for master students, and the 3 different locations. Additionally, we have the information that in the course of a study, 100 of the Düsseldorf bachelor students are considered in more detail. From this sample or subsample, in a second step, 4 different students are selected for in-depth interviews. Then we get our 2 tasks for this. First off, what is the probability that all 4 selected students will quit their studies? And B, what is the probability that of the 4 students, at least 1 will quit his studies? Well, before we actually start solving or answering these questions, we first have to clear why we are going to use the hypergeometric distribution here. Well, from the 100 students, we are going to select 4 different students. So that's more or less our selection process. That's the sample we're considering here. Well, if we're selecting 4 students for interviews, we're not going to do 4 interviews with exactly the same student. So implicitly in the sentence, we know it will be interviews with 4 different students. So once one of the students is selected, he cannot be selected again. And that's actually the definition of selection without replacement, which then necessitates the use of the hypergeometric distribution. So yeah, we're going to use the hypergeometric distribution. And well, with this in mind, let's start with part A. Here, what we're looking for is that all 4 of the selected students for the interviews actually will quit their studies. So here, small k is 4. So we're looking for the probability that 4 students show this property. We know we have 100 students in total. We have the sample size of 4 students, which we consider for the interviews. And we know that of the 100 students, 15 will most likely quit their studies. That's the information we get from the table. It's about Düsseldorf bachelor students, and they had a quitting rate of 15%. So 15% of the 100 means we can expect 15 students to quit. With these 4 numbers, we actually have everything we need for calculating the wanted probability, because here we can simply insert these numbers into the probability function of the hypergeometric distribution. So first off, we have large K over small k, so 15 over 4. Then this side we have large N minus large k over small n minus small k. Well, what is this? That's actually the people who have the property we are talking about here. So this part is about those students who quit. There are 15 students in total who will quit. 4 of them should be in the sample. This is about those students who do not quit. So on average, there's 85 students who will not quit, and we want 0 of them in our sample. And below here, we have large N over small n. That's how many students in total we have in general and in our subsample. And well, if we insert those numbers or put them into calculator, we get a result of 0.03%. So in total, the probability that all 4 students we select will then quit their studies is just 0.03%. So not 3%, but 0.03 or 0.0003 if you write this as a number. So very, very small. Well, that was the first part. That was part A. So let's do the second part of this exercise. Here we're going to look for that at least one of the students will quit. So it should be larger or equal to 1. Equal meaning it could be 1 student. The larger than means could be 2, 3, 4 students. Well, here we would actually have to calculate the probability of it being 1 student, 2 students, 3 and 4 students. So we would have to calculate 4 probabilities. However, we can consider the counter probability, which is just 100% minus the exact opposite of this. Well, the logical opposite of larger or equal to 1 is smaller than, real smaller than 1. Well, smaller than 1 would mean we only have one possibility, because it needs to be an integer. The only integer which is possible here would be 0, and well, only possible and being smaller than 1. So we can actually turn this around into is smaller than 1, and smaller than 1 translates into it's equal to 0. So we only have to calculate, in this case, if we work with the counter probability, one of the probabilities and not 4 as if we were to calculate this step by step. So this saves a lot of time. Well, we know with this that our small k now is 0, and we have the same information as on the slide before. So we're simply going to insert these numbers again in the probability function of the hypergeometric distribution. Now we have 15 in our sample, 15 students who will quit. In our subsample we want none of them because it's 0. We want, however, of the 85 who will not quit, 4 in our sample, and in total it's still the same, it's 100 over 4. Those 100, those 4. If we put this into the calculator, we get 1 minus 0.5164, or in total as a result 48.36%. So the chance that at least one of them will quit, one of those students selected for the interviews will quit, is slightly over 48%. Well, that's then everything there is to this exercise, to this last part and to the exercise in a whole. So I hope you enjoyed it. I say goodbye and see you next time.